Here's your guys' practice test number 2. Okay, practice test number 2. So here you guys gotta simplify the expression. So since there's a subtraction sign, probably get common denominators. So on this side, I'm gonna multiply both sides, top and bottom, by a plus 4, and on this side, multiply top and bottom by a minus 1. So on top, you're gonna distribute this stuff, and please do not forget, if it's a minus sign, attach the minus sign to the one up top. So you guys will get a common denominator of a plus 4 times a minus 1, and then 5a times a is 5a squared, 5a times negative 1 is negative 5a. Over here, negative 2 times a is negative 2a, and negative 2 times 4, you guys, is negative 8. So combine like terms, so the only ones you guys can combine is the minus 7a from up top. So this would be your guys' final answer, which looks to be like number A. Okay, so there's that. Number 2. Now again, we need to get common denominators. So on this side, multiply this side by n minus 2, and this side multiply by n plus 1. Distribute the 4. So you guys are going to get 3n times n for 3n squared. 3n times negative 2 is negative 6n. 4 times n is 4n, and 4 times 1 is 4. All over n plus 1 times n minus 2. Simplify the top, and you guys get 3n squared minus 2n plus 4 all over n plus 1 times n minus 2. So for this one, the correct answer looks to be A. Looks to be A. Okay, number 3. Now, multiplication, rational expression, so you guys have to factor everything. So this one, you can factor out a 3 to get n plus 10. This one, you guys could do your x method, so it's going to be n plus 4 times n plus 10. This one, x method again, so it's going to be n minus 5 times n plus 4. And this one at the bottom, you guys, another x method factoring, n minus 4 times n minus 5. And now we cancel away, right? N plus 10s cancel, n minus 5s cancel, and n plus 4s cancel. So all we're left with is 3 over n minus 4, which looks to be A. Okay, so 4. So for you guys, now we do have to flip this over. So I'm going to rewrite all of this stuff. Times now, going to change division to be multiplication, and you guys take the reciprocal of this. So x plus 1 all over x squared plus 2x minus 8. And now it's time to factor. This will become, you can factor out a 7x to make it x plus 4. You can factor out a 7 from there to make it x plus 1. And you guys can factor out x method from there to get x plus 4 times x minus 2. So the x plus 1s cancel. X plus 1s cancel, the x plus 4s cancel, and this 7 cancels off with that 7. So all we have left is x over x minus 2. What looks to be B. X over x minus 2. Okay, number 5. So we have to solve for this equation. So first we should factor all our denominators. So both of these factor into, you guys, k plus 3 times k minus 3 for both of them, right? So denote what k cannot be. So k cannot be negative 3 and it can't be 3, because that would make these denominators 0. So multiply the whole thing by k plus 3 times k minus 3. So this times this, you guys, the k plus 3 and the k minus 3 just cancel. So all you're left with is 6k plus 12. This times this, you guys, again, the k plus 3 and k minus 3, they all cancel. So all that's left is negative 6. And equals this times this, you guys, the k minus 3's cancel. So all that's left is k plus 3 and the k minus 4. So here we're going to have k plus 3 times k minus 4. Now we do double distribution here, and on this side, you guys, we can combine these two. So 6k plus 6 equals k squared minus 4k plus 3k minus 12. So clean that up. K squared minus k minus 12, and because we're dealing with a second power, we gotta set this whole equation equals to 0. So I'm gonna move the 6k over, and I'm gonna move the minus 6 over. 0 equals k squared minus 7k minus 18. We factor that using your guys' x method, so it's going to be k minus 9 times k plus 2, so k equals 9 and k equals negative 2. In the beginning, we said k cannot be negative 3 and 3, so we're perfectly fine. So our final answer is going to be D. It's going to be D. Number 6. So again, we should probably factor everything we can from the denominator. So x times x plus 4. So we know x cannot be 0 and it cannot be negative 4. So multiply the whole thing, you guys, by x times x plus 4. So this times this, you guys, they cancel. So all you guys have is 2x plus 6. Here times here, you guys, again, they'll all cancel. So all that leaves is the plus 2. And this one times this one, you guys, the x's cancel, so all that's left is the x plus 4 and the x minus 2. And now we distribute that. On this side, the 6 and 2 can combine, so 2x plus 8 equals x squared minus 2x plus 4x minus 8. So you get 2x plus 8, x squared plus 2x minus 8. And since we're dealing with quadratic, we gotta set the whole equation equals to 0. So all of this is gone, so all you guys have left is 0 equals x squared. These are gone, and we have minus 16. So how do we factor this? Well, we have the difference of squares factoring, right? X plus 4 times x minus 4. So x equals negative 4 and x equals 4. But if we look at what we wrote in the beginning, x cannot be negative 4. So this is not an answer. So our only answer should be x equals 4. 4C. X equals negative 4 is what we call an extraneous solution, right? Extraneous solution. Okay, next, so here we have to graph. So we just have to get enough information to tell us what we need. So first, I'm gonna find our y-intercept, you guys. Set the equation x equals to 0. So if you guys plug in 0 into here, well, all we're gonna have then is negative 4 over negative 4. So negative 4 over negative 4, which you guys is just 1. So the y-intercept is just 0, 1. Okay. 0, 1. So we can eliminate this one, you guys, because that's not 0, 1. And we can eliminate this one, you guys, because that 2 is not 0, 1. So it's just a debate between B and C, right? Now let's get the horizontal asymptotes. So if we look at the degree, so remember all of this terminology, you guys. If the numerator degree is higher than denominator, horizontal asymptote's none. If they're equal in degree, then you gotta look at y equals the coefficients. And if the numerator is less than the denominator, then the horizontal asymptote is y is equals to 0, right? So that's some good information to help us. Now let's take a look, right? Well, the degree up top, you guys, is 1, and the degree on the bottom is 2. So the numerator is less than the denominator, so the horizontal asymptote, you guys, is y equals 0. So when you guys take a look at this, this certainly has a y-intercept at y equals 0, and it has a y-intercept at 1. So that one's looking pretty good. We're not going to have a slant. And if you guys did factor all this stuff out, you would realize that those would cancel, so we do have a whole and so set the whole equals to 0, right? And we do have a whole at 1. So there is going to be a whole here. So I'll finish this off, but you guys try to get little bits and pieces of information, right, to tell you guys how to find this. So x equals 1, so plug it into the reduced equation. So we get 4 over 1 plus 4 for 4 over 5. So the whole is at 1 comma 4/5. And your vertical x-intercept, you guys, well, you would set the numerator equal to 0, but 4 cannot equal to 0. So there is no x-intercept. And to find the vertical asymptote, you guys set the denominator equals to 0. And x equals -4. So all of this information seems to line up with there, but you guys try to find enough information in order for you guys to do this. Number 8. So remember, for these type of problems, you guys, this says left 2, right? And this one says up 2. And if we graph the parent function, you guys, it's -4 all over x. And remember, your guys' horizontal asymptote is y equals 0, and your vertical asymptote is x equals 0. Okay, so remember when you guys did a table for this, -1, if you plug in -1 into here, you guys get 4, and if you guys plug in 1, you guys get -4. So if the parent function was this, you guys, right? And you move it left 2 and up 2, so left 2. So if it's -1 comma 4. So I'm graphing right here the parent function, you guys. So this is the parent. And now if you guys move everything left 2 up 2, well, where does it look like it go? Well, left 2 of this, you guys, so the vertical asymptote would be left 2 then, right? And your vertical asymptote went up 2. So it should look like that, and it should look like this to some degree, right? So which graph represents that? To me, it looks like C. It looks like C. And that looks good to me because the vertical asymptote went left 2 and the horizontal went up 2. And the points seem to match up as well. -4 comma 4. Oh, -3 comma 4. But yeah, that seems to be pretty good. That seems to look pretty good. So that is the correct answer right there. Okay, this one. So we gotta break all these down, right? So three, 4, 2, 2, 2, 4, 2, 2. Pairs of 2's, leftovers. So -2 rad 2. Pairs multiplied to the outside for 4, square root of the leftover 3. Pairs of 2's multiplied to the outside, so -6, square root leftover 2. You can combine these. So -2 minus 6 is -8, square root 2 plus 4, square root 3. That's A. 10. Again, we gotta break all of these down. But now we're trying to find groups of 3. So here's a group of 3. We got 2 leftovers over here. Here's a group of 3, and we got a leftover right there. So -cube root of 4. This group of 3 times it to the outside for -6 cube root of the leftover 3. And over here, 2 times 2 is 4 cube root of the 2 leftovers. 2 times 2, 4, 4. We can't combine these because they have the same radicand. So negative 1 plus 4 is 3, cube root of 3. Oh, cube root of 4 minus 6, cube root of 3. And that one looks to be D. That one looks to be D. Number 11, so multiplication. So I would just multiply outside times outside and inside times inside. So we get 60 and then break this down, right? Pairs, left over 3, left over the 5. So 3 times 5 is 15. 15 times negative 15, you guys. Well, 5, 2, 75, 5, 1, 5, 2, 1, 225. So negative 2. Oh, what am I doing? Sorry, the group we multiply to the outside, so that's negative 30. 2 times negative 15 is negative 30, and the leftovers is 3 times 5 for 15. Negative 13, radical 15. 12. So we should probably break these ones down, right? We should probably break these down. So that's 2 and 9, 3 and 3. And this is 3 and 4 and 2 and 2. So this one, it doesn't seem like we could break this down, so we're gonna have to multiply these across. So negative 15, cube root of 18 times 12, 36, 6, 1, 216. Oh, perfect. 216, you guys. Well, if we break this down, 2 and 108, 2 and 54, 6 and 96, 3 times 3, and 3 times 2. There's a group of 2's right there. There's another group of 3's right there. No leftovers, so 2 times 3 is 6. 6 times negative 15 is negative 90. No leftovers, so answer is going to be A for negative 90. Okay, here. Now, multiply top and bottom by square root of 10, and we get square root of 80 all over 2. Radical 10 times itself is just 10. So I got radical 80 all over 20. So let's simplify the square root of 80, and we would get 8 and 10, 4 and 2, 2 and 5, 2 and 2. Pairs, pairs, leftover. So radical 80, you guys, is going to be 2 times 2 for 4, left over square root of 5 all over 20. And simplify this fraction, you guys, dividing top and bottom by 4 for square root of 5 all over 5. And that answer would have been D. 14, so multiply top and bottom, you guys, by the conjugate of the denominator. So 2 minus rad 3 to top and bottom. And this is where we got to do our double distribution. And then here, 2 times 2, and then rad 3 times negative rad 3, right? So 3 times 2 is 6. 3 times negative rad 3 is negative 3 rad 3. Rad 3 times 2 is just 2 radical 3. And rad 3 times negative rad 3. So positive times a negative is a negative, and rad 3 times itself is just going to be 3. All over 2 times 2 is 4. Minus rad 3 times itself is just 3. So on top, we can combine the 6 minus 3 for 3, and we can combine these two. Negative 3 plus 2 is negative 1 radical 3, all over 1. So this answer is just 3 minus radical 3 for B. Number 15. Okay, so this is solving your guys' radical equation. So raise both sides to the second power. 4p minus 3 equals p minus 2 times itself. And we got a double distribution right there. So we get 4p minus 3 equals p squared minus 2p minus 2p plus 4. 4p minus 3 equals p squared minus 4p plus 4. And since we're dealing with quadratics, set the equation equals to 0. Minus 4p to both sides, add 3 to both sides. Because that becomes 0. p squared minus 8p plus 7. Factor this, so we get p minus 7 times p minus 1. So p equals 7 and p is equals to 1. The only thing is we have to plug this back in to make sure both of these are fine. If we plug in 7 into here, well, 4 times 7 is 28. 28 minus 3 is 25. Square root of 25 is just 5. And 7 minus 2 is 5. So 5 equals 5. This one works out. But how about this one? Well, if you guys plug in 1 into here, 4 times 1 is 4. 4 minus 3 is 1. Square root of 1 is just 1. So this side's positive 1. But if you guys plug in 1 into here, that'd be negative 1. A positive 1 does not equals negative 1. So that means this cannot be an answer. So your only answer should be 7 for A. So you guys try the same thing over here. So raise both sides to the second. We get 4m minus 16 equals m minus 4 times itself. So you guys got to double distribute there. 4m minus 16 equals m squared minus 4m minus 4m plus 16. 4m minus 16 equals m squared minus 8m plus 16. And again, since we're dealing with another quadratic, set the whole equation equals to 0. So m squared minus 12m plus 32 is what we have. And the factors will be m minus 4 times m minus 8. So m equals 4 and m is equals to 8. But again, we have to plug this back in to make sure that it's fine. So if we plug in 4 into here, well, 4 minus 4 is 0. 4 times 4 is 16. 16 minus 16 is 0. So 0 equals 0. So this answer is perfectly fine. If you guys plug in 8 into here, well, 8 minus 4 is 4. So this side's 4. 4 times 8 is 32. 32 minus 16 is 16. Square root of 16 is 4. So 4 equals 4. This one also works. So your answer should be A, 4 and 8. Okay, this one. So this one's helping you guys to realize that you have an exponent and you need to change it to be a radical form. So the square root of 4n n to the 49 n to the 4th, all raised to the 3rd power. Well, square root of 49, you guys, if you did this, it's 7. And then, well, if you guys did your variable stuff right, 2 goes into the exponent of 4 twice with no remainder. So it's going to be n to the 2nd. Raised to the 3rd. So 7 to the 3rd power, right? 7 times 7 times 7, and then n 2 times 3, and to the 6. So 7 times 7 times 7, you guys, is 343, and to the 6, which is A. 18, so change this to be cube root of 64x to the 3rd, all raised to the 2nd power. So again, you guys can break this down. And if you did break this down, you would realize that there's that group of 3 and this group of 3. So 2 times 2 is going to be 4. And how many times does this exponent of 3, this index of 3, go into the exponent of 3? Once, with no remainder. So it's just going to be 4x. All raised to the 2nd power. So 4x times 4x, you guys, that's 16x squared, which is A. And then here we go. So the parent function of this, you guys, looks like 3 cube root of x. And if you guys did do a table, -1, 0, and 1, plug in -1, and you guys get cube root of -1 is -1, and -1 times 3 is -3. Plug in 0, 0. Plug in 1. The cube root of 1 is 1. 1 times 3 gives you guys 3. So your graph, you guys, -1, comma, -3, 0, comma, 0, and 1, comma, 3, looks like that. So it's gonna look something like this to some nature. But then look at your guys' translation. Left 3 and up 1. So this whole graph, you guys, gets moved left 3 and up 1. So left's 3 and up 1, you guys. That definitely looks like to be D. And if you guys did move these all left 3 and up 1, then one of them should be at -6, comma -6. Wait. Yeah, left 3, so -4, comma -2. And yeah, that looks to be pretty good. So it's D. 20. So remember your guys' parent function. It's 3 radical x, right? 0, 1, and 4. Plug in 0, 0, plug in 1. Square root of 1 times 3 is 3. Plug in 4. Square root of 4 is 2. 2 times 3 is 6. So you at least know, you guys, 1, 3, 4, 3, 4, 5, 6. So your graph looks something like that. And when you guys move it left 2 and down 4, we'll move all these coordinates left 2 and down 4. And what you guys will notice is left 2 down 4 is D. So definitely use the translations to help you guys locate which graph you need to find. And if you need to make tables, the parent function tables, then definitely do so. Okay? So hopefully this helps you guys out, and just, keep on practicing. Keep on practicing all this stuff. Okay, guys? Good luck studying for your guys' test. Peace.